Welcome to the Explainer. Today we're jumping into the amazing world of alkenes. These are the molecules that, believe it or not, connect things like plastic bags and ripening bananas.
I know, it sounds like the beginning of a weird joke, right? But the answer is actually this really special family of molecules that are all around us, constantly building and changing our world. So, let's get ready to meet the alkenes.
Okay, so let's start with what really makes these molecules tick: the double bond. This is the absolute key to understanding why alkenes are so unique, and it's a story of both incredible strength and, well, a very useful weakness.
So, what exactly are these things? Let's go ahead and pull up their basic identity card and get to know the alkene family a little better. The most important word on this slide is unsaturated. You can think of it like this. An unsaturated molecule is kind of like a bus that still has a few empty seats. It has room to let more atoms come on board. And that's all because of that one special feature, the carbon-carbon double bond.
And here's where it gets really elegant. Check out the recipe for an alkene. It's so simple. Whatever number of carbon atoms you have exactly double the number of hydrogen atoms. It's this perfect, clean 1-to-2 ratio every single time.
And you can see that perfect ratio playing out right here with the first few members of the family. Ethene, propene, butane. Look at them. They all follow that same simple rule. It's like a chemical family where everyone looks exactly alike. All right, so let's dig into the big question. Why are alkenes so much more reactive than their molecular cousins? Well, the whole secret is hiding inside that double bond. And it's probably not what you're thinking. That's right. It's not just one super-duper strong connection. It's actually a team of two very different bonds. You've got one that's like a rock-solid foundation, and another one that's, well, it's kind of just looking for an excuse to react with something.
And this right here is the whole double-edged sword thing we were talking about. You see that sigma bond? That's the strong backbone, the core connection holding the whole thing together. But then there's the pi bond. It's weaker, it's more exposed, and it's basically the weak link in the chain that's just begging to be broken. And that's where all the magic happens. So now, let's see how this supposed weakness is actually an incredible superpower. That breakable pi bond is what lets us do some pretty amazing chemical construction and build some really cool stuff with alkenes. I want you to picture that pi bond breaking like a set of double doors swinging open. All of a sudden, you've got two new open spots, and new atoms can just waltz right in and join the molecule. This simple act of opening up is the key to pretty much everything that makes alkenes so useful. Now, what if you did that over and over and over again? Imagine linking together a massive chain of paper clips. That's polymerisation. You take thousands, sometimes millions, of these small alkene units, and one by one, their double bonds pop open and they link together into this one gigantic chain. This is how we make some of the most important materials in our world.
For example, let's take ethene. It's just a simple gas. But if you get thousands of these little guys to link up, you create polyethene, which you definitely know is the plastic that makes up everything from your grocery bags to your shampoo bottles. So you go from a simple, invisible gas to a tough, versatile plastic that is literally everywhere. And it's all thanks to that one easy-to-break double bond. I mean, that's the power of alkene chemistry, right there in your hands.
But it's not just about making plastics. You'd be surprised where else you can find alkenes. They show up in the chemistry lab, sure, but also in the fruit bowl sitting on your kitchen counter.
They are absolutely essential building blocks. We use them to make alcohols and detergents. And yep, that same alkene, ethene, is the plant hormone that tells a banana it's time to get ripe and sweet. They really are the unsung heroes of our everyday lives. Okay, so if alkenes are all around us and their big thing is that they're super reactive, how do we actually know if they're there? Well, it turns out there's a really simple and surprisingly colorful way to spot one.
It's called the bromine water test. Check it out. On the left, if you add this brownish liquid to a stable alkane, nothing happens. The color stays the same. But add it to an alkene, and bam! Those double bonds swing open, they grab onto the bromine, and the brown color just vanishes. It's like a little magic trick that lets you see chemistry happen right before your eyes.
This table really just pulls it all together perfectly. The difference between a single and a double bond might seem tiny, but as we've just seen, it completely changes the game. It's what makes alkenes unsaturated, way more reactive, and just incredibly useful. You know,
When you think about it, going from a single bond to a double bond is such a small change at the molecular level, but it has this absolutely monumental impact on our world. It's a pretty powerful reminder that sometimes the smallest little details can make the biggest possible difference. It really makes you wonder, what other tiny changes are shaping our world in ways we don't even see?